Hey there, U12s. We've got a question for exercise 4C, question 7c. In order to do this question, it relies on your answer from B, but assuming you haven't done B either, then in B it says, if this particular cubic equation is equivalent to this expansion, I guess what you need to understand is this expansion is exactly C and B are linked in that form. So what you need to figure out first is, well, what is a times x plus c cubed plus b expanded to? Because what you notice is that this is in a factorized form, whereas the question that they're giving to you, notice this is in expanded form. So that means if you want to do a comparison and you want to sort of solve the problem, one of the ways is solving by comparison is that you need both of them to be in the same form to do a comparison. So since this is already expanded form, so I'm going to write out x cubed minus 5x squared minus 2x plus 24. This has 1, 2, 3, 4 terms where you can see this represents the x cubed, this is the x squared, this is the x, and this is the no x's, which is the constant term. Your aim is to expand this side to do the same thing. I need an x cubed term, I need an x squared, I need an x, and then a constant term when I expand them. So here we go. To expand this, we can see that this is a multiplied 2. Now this is a x plus c cubed, and hopefully you know your binomial expansion. Otherwise you could do x plus c times x plus c times x plus c, and that would work as well. But assuming that you know how to do the expansion of x plus c cubed, that is using this formula that you would have picked up from either Pascal's triangle or something like that, you know that this is, we always started with a cubed, and then the next one would then be a squared, next one would then be a, and then there will be no a's, but then the b term would then be b to the power of 0, this would then be b to the power of 1, b to the power of 2, and then b cubed. So that's the pattern that you can see there. Normally we don't write b to the power of 0, we just write a cubed there. And then the Pascal's triangle, which we know the coefficients is 1, 3, 3, and 1. Okay, so again, if you didn't know this, you can derive this formula by simply doing a plus b times a plus b times a plus b on your CAS calculator, and you should be able to get that formula there. Okay, so expanding it now, that means my a is my x, so that becomes x cubed plus 3 times, what's that, x squared c plus 3 again, x times c squared plus c cubed plus b. Okay, so I'm just going to delete this side so it's less confusing. Actually, maybe I'll just move it aside. What have I done? Okay, there we go. So now we've almost got the expansion form, but we can't really compare it because this is still in a bracket. So what I'm going to do is I'm going to expand the bracket and I'm going to multiply them all together. And what we can see here is you get ax cubed plus 3ax squared c, or maybe I should do ac x squared plus 3ac squared x plus ac cubed, and then I've got a plus b. Now what we can see now by comparison, can you see I've got this x cubed, I've got this minus 5x squared, I've got this minus 2x, and I've got this plus 24. So when we look at the x cubes, so here's my x cubed. So by comparison, just by comparison, since they're both equal, if those two are equal, then if the coefficient of x cubed right now is 1, well that means a must be 1. True? By comparison. Then I look at the x squared component, I'm like, that's my x squared over there, and the coefficient in front of it is a negative 5. So that means this right here, 3ac, must equal to negative 5. So negative 5 is equal to 3ac, but we already know that a is equal to 1. So really you're saying negative 5 is equal to 3c, and from here we can work out c by dividing 3 on both sides. So negative 5 on 3 must be c. Okay, so you see what I'm doing? I'm just doing it by a comparison. I'm just adding them all together, and you can see over here we're looking at the x component, and the coefficient of it is currently negative 2. whilst this is 3ac squared. So I can then put them together and say, well, that must mean negative 2 is equivalent to 3 times a, which is 1, times c now we know is negative 5 on 3 squared. Actually, well, you don't actually need to test that. Actually, we should test whether that actually equals each other. So that becomes 3 times negative, 25? Sorry, positive 25 on 9. This is probably why. So you can see here 25 on 3, that is not equal. So it shows that the expansion of your form, you cannot factorize in this form, because if you do, the coefficients of x do not match. That number should be negative 2, but yet over here, if I've got a and c correct for these first two, then the other two don't work. Okay, so that's why we know that that is impossible for it to work. Had it actually worked, that the ac squared, the 3ac squared would have worked for this component, then that means it should work for the last component as well. So 24 ac cubed plus b should actually work out to be 24, but it looks like you can't satisfy this coefficient of x, and that's why when it says here c, show that x cubed minus 5x squared minus 2x plus 24 cannot be written in this form. Well, it can't be, because clearly this step is already a no-go, and that's how you would prove it.